A very warm hello to all my students. This is your teacher, Mrs. Numaira Zahid, and today we are going to understand Ohm's law, and we are going to find out how can we apply Ohm's law to our so many numerical problems related to voltage, current, and resistances. So as we know that Ohm's law is a law which is given by George Simon Ohm, and it is actually relating three quantities which are voltage, current, and resistance. So if three quantities are linked together, it makes up a law, and this relationship is called Ohm's law. So how can we find out what Ohm's law teach us? Ohm's law says that whenever we relate voltage and current, these two quantities are always related in direct relation. So whenever the voltage is changing in any direction, either it moves up or down. If voltage increases, it will increase the current. If voltage decreases, it will decrease the current. It means there is a direct relation between voltage and current. So, whenever we replace this proportionality with an equality sign, so it will become V is equal to I. And here, when we replace this proportionality with an equality, we have to place or input a constant value, which can be the resistance of a substance of a material. Because whenever current flows through a conductor, that conductor has a specific resistance, because resistance of different materials is different. Similarly, when we talk about V is equal to IR, it is the relationship between voltage and current, and the resistance of the conductor is playing the role as a constant value. So voltage is equal to current multiplied by resistance. Whenever we need to find voltage, if we want to calculate voltage, we are going to take the product of both the values of current and resistance. Let's say, for example, if we have a given value of, given that the current is 40 amperes and the resistance of the material is 20 ohms. Now, you need to find the voltage across the conductor. If you want to find the voltage across the conductor, then you are using Ohm's law. V is equal to IR. So to find voltage, we are putting 40 amperes as the current and 20 ohms as the resistance. These two values are already given. So when we multiply 4 two times is 8 and 100, 800 volts. So the voltage across the resistance, the voltage across the conductor is 800 volts with the resistance of 20 ohms and a current of 40 amperes. Similarly, we can find out current and resistance too with the same law. So using Ohm's law to find current, given that if you are given with a voltage of 220 volts and a resistance of 20 ohms, you need to find out the current flowing through the conductor. So if you want to find the current flowing through the conductor, we have I is equal to question mark. If this is the situation, then by Ohm's law, V is equal to IR. So here we have the value of V as 220 volts and R as 20 ohms. But we need to find I. So how can we make I as the subject? When we move this R to the opposite side, it will become a denominator here, and we are making I as the subject. So if I is equal to V over R, We can find it out by dividing 220 by 20. So if 0 cancels 0, we are getting I is equal to 11 amperes. Got it? This is how we can use Ohm's law to find current through a conductor as well. Now the last quantity which we are going to discuss, how can we find out resistance? So if it is given that voltage is 220 volts and current is 11 amperes, we need to find the resistance of the conductor. Find the resistance of the conductor. What is the resistance through the conductor? So R is equal to question mark. In this situation, we can use Ohm's law. By Ohm's law, we get V is equal to IR, and making R as the subject, V is equal to I. So R is equal to V over I, which can be found as 20 ohms. Got it? This is how we can use Ohm's law to find all three quantities which are in relation in Ohm's law. That is, V is equal to IR. If it is beneficial for you, you can share it with your friends. Thank you.